All right, so my name is Edgar, and we're going to be talking about productionizing H2O models with Apache Spark. If you're not familiar with the H2O platform, it's okay. We're gonna cover it, and if you're not familiar with the ML pipeline part of Apache Spark, we'll also cover some of that too. So just to figure out how we can tune this talk, if possible, by a show of hands, how many people here are comfortable with the data engineering and feature engineering parts of a lifecycle? Okay, cool. Yeah, in that case, so we'll go over each one of these phases, and if there are any questions, stop me, let me know, and we'll make sure we have a solid understanding before we move on. So a machine learning lifecycle, the first phase is data engineering. And that typically, the operations that are part of that are things like pulling data from multiple sources, joining that data, cleaning the data, removing any invalid values, generally what is considered data prep and data cleaning. So if I say data prep and data cleaning, I mean the data engineering phase. After that phase, when you've got data prepared in a way that makes sense, you pass that data on to the next stage, feature engineering. So the point of machine learning is to extract signals from data, which means that the data that you try to predict on needs to have columns that are meaningful. The data in the set needs to be enriched in a way where you can actually extract signals. So take for example a data set where you have a row, and that row is a timestamp. It's a number of seconds since the epoch, right? So it's just this long. If you're trying to predict something using a time column and you're going to train on just this long, it doesn't really make intuitive sense. How do you correlate, whatever you're trying to predict with, just this ever increasing long? Maybe what makes more sense is to transform or featureize this data and go from this timestamp, seconds since the epoch, to something like what day the timestamp falls on, whether it was a weekend or a weekday, whether it was the afternoon or evening, if it fell on a holiday, something like that's a bit more intuitive. We could probably extract the signal better from that. Feature engineering is a very iterative and very involved process. You don't typically have one transformation, you have many transformations. The next part of the pipeline is the application of the training algorithm. And that is also very iterative and very experimental phase, and it's the result of that phase, the application of the training algorithm, that results in what we call the model, or a model. And it's the model that, when pumped data through, gives you training predictions. So that's how you build a model, but you also need to deploy the model. And typically the way pipeline deployment looks like is you have this model and you deploy it to some environment. But it's not just this model that you have to worry about getting up, it's also the featurization pipeline, the transformations that you performed on your input. Those also need to be brought into your deployment environment to prep the data and give your model, your model needs to see the data coming in the same format that it saw during training. So you also have to bring in this second component. So we're going to go over two example implementations of the machine learning lifecycle. The first implementation is going to use the Spark platform for data engineering and feature engineering, and then for the training phase, we're going to use the H2O platform. It wasn't too long ago, some number of years ago, you might have done a web search for Spark MLlib versus H2O. And you may have come across posts that said something to the effect of, well, you should use Spark because it's great. You have the support of an entire ecosystem. You use it for more than just machine learning algorithms. it handles a lot of use cases, and it's a great tool. But on the other hand, you have the H2O platform, and it's built from the ground up to be very performant, and the benchmarks are fantastic. It's built for machine learning experts, and so you had to sort of weigh this, all right, do I go with this awesome ecosystem, or do I go with this really performant platform? That was that weighing was done away with the introduction of a unifying platform, sparkling water. Actually, let me go over what H2O is. The H2O platform, you can think of it as a machine learning library. So it's this platform that that builds models for you. It's really built for machine learning experts. It exposes a lot of tunable options and hyperparameters. It's built in a very distributable way. Most of the advanced algorithms that you'd want to run are available and built into the H2O platform. So Sparkling Water was this unifying platform that brought the best of two worlds. It brought in H2O into the Spark ecosystem. And the way it did that is very transparent. Instead, it was built with the Spark user in mind. So as a Spark user, if you're using Spark in a Python notebook or in a Python script or in Scala code, what have you, and you want to incorporate H2O models, you now don't have to go into a different environment. You can do everything from the Spark environment and in the Spark ecosystem that you're already used to. So I think it's really important to note that Sparkling Water does not combine Spark and H2O. It's not some like monolithic platform. It's really just the seamless connector between the two. So how does the lifecycle that we went over look like with the introduction of Sparkling Water? Specifically, how does the first example implementation look like? So we are going to use Spark for the data engineering and feature engineering phases, and then the H2O platform for the training of the model by, yes?
Just to be clear, so that distinction is that the H2O has its own runtime. Spark has its own runtime, and they transfer data somehow, right? They dump it to disk or...
Yeah, good question. And so that's exactly what I was going to talk on. So you have so that interface between feature engineering and the model training. Typically you need to make that conversion somehow. But with Sparkling Water, there is a very seamless transition. So you have after feature engineering, you have a data frame, a Spark data frame, but H2O expects an H2O data frame. So what Sparkling Water lets you do is within your Spark environment, after you've done feature engineering and you have this Spark data frame, you just you pass it in. There's this conversion that you can do. It's a single line of code. It's a single command that takes Spark data frame and gives you back an H2O data frame. And then from there, in the same environment, you call the H2O platform, and then H2O takes over.
You guys use Tungsten underlying also?
Sorry?
You guys use Tungsten underneath? Tungsten?
Constant?
Tungsten.
Oh.
Oh, sorry.
Yeah.
Is Tungsten your underlying format for that Spark data frames?
I can't say with 100% certainty, but
Okay.
Ah,
So you do an actual conversion.
Yeah. And so specifically, so if we're talking about conversions, just a bit more information. So if you go from an H2O data frame to a Spark data frame, what happens is Sparkling Water creates this very lightweight wrapper around the H2O data frame, and this wrapper you can use with the Spark API. So for all intents and purposes, it's a Spark data frame now, and just it's a wrapped H2O data frame. If you go in the other direction from a Spark data frame to an H2O data frame, Sparkling Water does have to read the data from the data frame and store it in the H2O data store. But the data there is very highly compressed. There's not any data duplication going from H2O to Spark, and the other way the data ends up being very compressed anyway in the H2O data frame. Yeah, thanks. Good question. Oh, yes.
You want to use the mic, please? So sorry about this stupid question, but why would you convert it from Spark to H2O? What's the benefit versus just doing everything in Spark using MLlib?
Yeah, good question. So, the way I understood the question was, why use H2O over MLlib? Because if you use H2O, you do need this conversion somewhere, and so sparkling water makes that conversion seamless. So the question is, why use H2O over MLlib? H2O was built from the ground up to be and was meant for machine learning experts. So there are a lot of if you compare H2O to a lot of the other machine learning libraries, there are more exposed variables, exposed options and hyperparameters that you can tune, so you can get in deeper and tweak more. And also there are benchmarks out there. I don't want to say for sure. Rather don't take my word for it, but definitely look at benchmarks comparing MLlib, scikit-learn, and H2O. So I think benchmarks out there might provide a bit better context. And also a lot of H2O was built to be highly distributive. So a lot of the algorithms there were built in a way to maximize scalability and distributability versus some of the other libraries that don't. Good question. So. All right, so we have this model trained, and we need to deploy it. And so again, going back to the fact that we want to use Spark as the deployment pipeline. Our deployment environment, our production environment, is Spark. Right? It's a Spark cluster, local Spark, what have you. But we need to deploy two components. We need to deploy the model that we trained, and also the featurization pipeline that we did in Spark. Typically, again, you have these two components and you have to route data from one component to another, but because we're using sparkling water, it makes this transition, or rather this connection, seamless. So rather than have two components, really what sparkling water exposes is this combination of the two, where an H2O mojo now really is just another Spark transformer. You get the entire pipeline exposed as a Spark API. So in your production environment, you don't have this notion of a Spark pipeline and then an H2O pipeline. You have a Spark pipeline that happens to leverage the H2O platform underneath the hood. Cool. We'll go over a quick demo of just the. Okay. Oh. I don't see it. All right. We're going to go over a demo of just the top. Whoa. All right, let's do this.
Can you make the slides available?
Yeah, for sure. Good question. So this is we're going to demo the top phases. So specifically feature engineering through Spark, and then building a model with H2O. So we're in a Spark environment, right? We're going to make sure the Spark session is available. We're going to import some libraries. We're going to start an H2O context. If you're familiar with a Spark context, an H2O context is similar. We're going to import our data. And here you see we're using the import function from the H2O library as opposed to one of the. Oh, yeah, thank you. Yeah, thank you. So we're going to use the import file function from H2O as opposed to one available in Spark, because this import file function is really nice. It recognizes a lot of different file inputs, file formats, and I don't want to say it covers edge cases, but it recognizes a lot of oddities in your input data and different formats for like CSV and whatnot, and so running this typically just works. All right, so feature engineering. This is going to represent our feature engineering phase. Specifically, we're going to use Spark to create an SQL transformer. So I should probably go over what our use case is here. So internally, we have records on how long machine learning jobs took to complete, given some metadata. So we've got records on what platform a machine learning job was run on, Windows, Linux, Mac, how many rows the training set had, how many columns, things like that. And so we want to train a model to predict, given just metadata about a machine learning job, we want to predict how long this job will actually take to run. And so we're going to, as a part of our feature engineering phase, we're going to filter out rows, filter out the records that have less than 30,000 in that column. And so that's it for feature engineering, very basic example. The next stage, remember, after feature engineering is the actual application of a machine learning algorithm. So here we're going to use the H2O, one of the H2O libraries to perform automatic machine learning. And so what this does, in a nutshell, from a mile away, given the parameters, in this case a max runtime of 60 seconds, it's going to generate the best model possible. So I'm not going to wait for that to finish. It's not going to be executed yet, but we won't wait for it to finish when we get down here. So at this point, we've defined a feature transformation and also the model training stage. And now what we're going to do is, so up until this point, it's just been really Spark with a call to H2O. And so what we're going to do is we're going to create a Spark ML model. This is just straight up Spark. And we're going to tell Spark that the stages of in the pipeline should be composed of two things: our feature engineering and this model training. There's no special conversion. Everything it's pretty seamless. It's seamless. And so of course what this defines is a Spark ML pipeline. Nothing weird or hokey pokey about it. Here we're going to take. So if you remember, we read the data as an H2O frame. So this was our input. We have to convert it to a Spark frame and then train our model on that input data. So we're not going to wait for it to finish, but of course it'll only take 60 seconds that was one of our parameters. Sure.
I'm a little confused. I thought we were going from Spark to H2O to model things. Why are you switching back from H2O frame to Spark?
Yeah, great question. And I think that's my fault in how this is organized. So here we go from an H2O frame to a Spark frame. That's a really good question. The reason we go through this conversion is not because so this frame here isn't the result of the training. This frame was actually the frame that holds our.
That's your original data.
Right.
Oh, okay.
Yeah, exactly. I actually forgot. That's why it failed. I forgot to run these. Yes, so it was that original data. We're not actually going back to Spark. Good question. Yeah.
At that point, can I do an explain on that train Spark data frame and get the physical plan out of there? Or?
Yeah. For all intents and purposes, you're back in Sparkland. It was just that you wanted to call H2O. Oh yeah, you wanted to call H2O, and you did it. Yeah, but for all intents and purposes, you're back in Spark. This is totally the Spark ecosystem that you're used to. So again, we're not going to wait for it to finish, but we can come back to it afterwards. Okay, so feature engineering and training models is not an easy feat. Again, admittedly, the H2O platform, like a lot of the other machine learning libraries, are meant for machine learning experts. They expose a lot of algorithms, XGBoost, distributed random forest, what have you, and it's up to the data scientist to figure out how you want to apply those models to your data, or rather those algorithms to your data. It's also up to you to figure out what feature transformations to make. And so it's a difficult feat for any machine learning library, or rather for someone using a machine learning library. So what if you're not an expert and you don't want to do the feature engineering and model generation yourself? Well, in comes driverless AI. Driverless AI performs automatic feature engineering and machine learning at the click of a button, or like 3 or 4 clicks of a button. And so we'll see that in a demo in a second here. So that brings us back to our different implementations. So we saw Spark handling the data engineering and feature engineering phases, and so now we're going to look at how Spark can handle just the data engineering phase, and then we pass the feature engineering and the training of the model to driverless AI. So we don't do feature engineering ourselves, and we also don't do feature engineering ourselves with the help of the H2O platform. We let driverless take care of feature engineering and machine learning on its own. So okay, so this is what our lifecycle diagram looks like with driverless in the loop. So we're using Spark for data engineering, right? Our data prep and data cleaning. And then we pass the work off to driverless, and driverless takes care of feature engineering and training, and then gives us back this resulting artifact. Oh yeah, so it works. I was afraid that my mouse wasn't going to show up. And so it gives us back this resulting model that was generated in driverless. So to deploy these pipelines in production, like what we saw in the other slide, you have 2 components, your featurization pipeline and your model, and you need to deploy both to production. Well, also similar to how sparkling water integrates H2O and Spark, driverless will take care of this unification for you. So what you actually have is actually this single artifact that together is called the driverless AI mojo. And so again, you're working with Spark, you have Spark in production, you don't want to have to have a different, you don't want to set up a different environment, and that's fine, because the way driverless AI is exposed is as a Spark pipeline. So you'll be in, and we'll see this in the demo, but you'll be in your environment, in your Spark production environment, and you load in the pipeline as you usually do through Spark, but you load in the driverless AI mojo, which is a pipeline, and it's just as you would any other Spark pipeline. So we'll see a demo of driverless AI. Let's hope it works. Okay, great. Here is our driverless UI. I've already imported the data set. Again, this is the metadata for the records of machine learning jobs. We're going to run a prediction job, and through driverless AI, you can select the target column. So what we want to predict is the total time that it takes for a machine learning job to finish. And so we've got a bunch of buttons and a bunch of knobs, and we can tune them. You can change how accurate you want the model to be. And of course, as you imagine, this increases the time it takes for the model to generate. You can also specify how much time you want driverless AI to spend on the model, and interpretability, which I think, at least given time constraints, is out of scope for this talk. And then you launch the experiment, and driverless will take care of the rest. Now I'm running this locally on a CPU, not a GPU, so it's going to be incredibly slow. Maybe not, but so I've already pre-built a model, and so we'll use that for this next phase of the demo. So let's assume that we finish this model, and so let's assume that we've finished generating the model in driverless, and driverless gives this artifact that it calls a mojo, which again, underneath the hood, we're going to load in as a Spark pipeline. So this is the way we do it. I've broken up this script into 3 partitions. The first partition is Spark. None of this. This is just Spark. This second partition is where some of the magic happens. So instead of what we do is we get our model file, this Mojo that driverless generated, and we're going to create a pipeline, a Spark pipeline from this Mojo, and that's pretty much it. So now we've got this pipeline. The rest is just Spark. If you're familiar with Spark transformations, then you know that you can call transform on a pipeline and a model is trained. And so here, for all intents and purposes, this Mojo, this driverless AI Mojo, is a Spark pipeline. And again, this is underneath the hood. This is just Spark. This is the regular Spark ecosystem that you're used to. So to prove that it works, I will just run. I should start generating data. So I'm going to start generating data. Of course, that's simulated, and then I'm going to and then I'm going to deploy. Oh, I should probably make the font larger. And we're going to deploy this. And so this is just that script that we saw. So it's going to take just a second, but so we'll come back to this. We do have to come back to this, but okay. So that is driverless. So again, going back to feature transformations, driverless takes care of feature transformations. In our example, when we did this through Spark ourselves, we had a single transformation, that SQL transformation. So it was a single transformation pipeline. But of course, in reality, you don't have a single transformation that makes up your feature engineering phase. You have at least an order of magnitude or 2 orders of magnitude more transformations. And so driverless is pretty smart and clever in the way it finds the best feature engineering phase and builds a feature engineering pipeline. So here is just here's a screenshot of what the feature engineering pipeline looks like for a build using driverless. It's a lot of components. It's doing a lot of things underneath the hood, more than a typical a non data scientist or non-ML expert could do. So okay, so we have we've got this model in production. Let's assume we've got this model in production, and everything's working fine. So everything's great, but a model isn't good forever. Especially when you're doing streaming data, data is never stationary, and so at some point you're going to have data drift, or a shift in the type of data that you're seeing come through the pipeline, and your model performance starts to degrade because your model wasn't built for that data, and so you need to make a call. You need to retrain that model, but you need to make a call as to when to retrain the model. You don't want to wait too long, because if you miss your change point, then your model becomes ineffective, and if you're using it for to make money, or especially something important, then it's not good. But also inversely, you don't want to wait you don't want to retrain too soon, because retraining is expensive. Not only does it cost time and money as far as resources for the training, but also if you are using a supervised method for for learning, then you are also spending time on labeling efforts. And so it gets very expensive to retrain unnecessarily. And so there has to be a way to monitor your model in production and try to figure out when is the appropriate time to retrain the model. When is the best time to do that? So there's this effort. Which we'll call mojo monitoring, because it monitors that output mojo, which you could think of as your model, right? And so you have this mojo, and generally at a very high level, we want to do something that we will consider enhancement. So we want to enhance this mojo so that you can take this new resulting artifact, deploy it just like you would any mojo, and again in this case you're just deploying it as a Spark pipeline. So you have this file that you deploy as a Spark pipeline, but now you want to enhance it. You want to sort of inject this its ability to monitor and provide metrics for you. And so the result of this is this enhanced mojo, this enhanced pipeline, which when deployed to your environment, in our case Spark, we will the pipeline will broadcast metrics about what's going on, and so we get information as to what's going on underneath the hood. That way we can track if part of our inputs are shifting and we're no longer seeing the kind of data that we trained our model on, maybe we should retrain our data, or excuse me, our model. So a quick demo of that. I said a quick demo of that. Where, All right. Oh, so there's our output from. Those are our predictions that we made with that deployment of the driverless mojo. I think. Oh, there. Yeah, it's just a little slow. There's a lot of things running on the machine at the moment. I'm gonna close a couple of things.
So this is just for knowing when to retrain the model?
Yeah, good question. So you can do a lot of things with when you have the ability to monitor. So really what you have underneath the hood is you now have metrics that are exposed to you, metrics at every part of the pipeline. So one use case is being able to catch this data drift and know when to retrain. Another use case would be let's say you have this marketing campaign that targets people of a certain demographic, and all of a sudden you see a spike in the records coming in, and you know that maybe this marketing campaign worked because now you've got an influx of different types of rows that you didn't necessarily see before. So really you have metrics, and you can do really anything with it. All right, this is disconcerting, so I might have to come back to this, but yeah, I may have to come back to this. But let me skip over this phase. So what you would do through this this UI is you upload a mojo, this original mojo, and what it does is it extracts the columns, the features in the mojo, and so you're able to select what features you want to monitor. At the end of the process, you are given this enhanced mojo. And this enhanced mojo, again, you deploy just like you would, a regular mojo or a Spark pipeline in this case. And when you deploy that on your environment and your model starts to make these predictions, you get metrics. And so these metrics, let's see, I think we're okay on time, so I'll So I'll bring up this, yeah. Okay, so we're going to feed in data through the pipeline here, just some simulated data because I stopped the other job. So if you remember, we deployed this. Underneath the hood, I've deployed the mojo that we get from this phase, and so now we have this enhanced mojo in production. And what I just did was I fired off some simulated data that is being predicted on by this model in production, and metrics are being broadcasted to us. And so here is, as part of this this enhancing the mojo process, we also get dashboards generated for us with the either sensible defaults, and we can set alert thresholds, so we can sort of tell this enhanced mojo what we want it to we tell it what we want it to monitor as far as columns, and also what types of values it should be looking out for before maybe it goes crazy and it fires off an alert, letting us know that either something's wrong or that it should, a model should be retrained automatically. And so this is just an example dashboard that's generated with through this enhancement process. I know it's kind of weird to see without going through the process, and I'm sorry. I hope it comes back up. Yep.
So this is always through time? Like a time is the only measure that we can monitor the... Only monitor through time the features? There is no other, like frequency, for example, or something like that?
Yeah, good question. So just to repeat the question, is the only thing are the only visualizations that we can make are they time series? So the data, you have data going through the pipeline, and so that's naturally time series because at any given time you've got you've got metrics. But really in the back end, you've got metrics, and so yeah, you've got time series, and you can operate on those. Really any type of transformation as far as either for visualization or transformation in order to get a visualization, right? Like trying to monitor or extract frequency, you can do, because really you just have these metrics now at your disposal. Yeah.
So I didn't fully follow how you got these metrics. How did you get to defaults? Is that something you're explaining?
Yeah, good question. And so that would be made clear. And let's see if. I wonder if I'm connected to the net. That might be the problem. Yeah. Okay. So that I think would be clarified by going through this exactly what this enhancement of the mojo is. But we're having internet issues. We got a couple minutes, so let me try and.
I think you have a PowerPoint like that.
Yeah, yeah. So, what we would see is this this bit here, where you have this interface and you upload a mojo, and you do some stuff on this interface. I was hoping I could show it to you. And when when you're happy with what you have, you can tell it to give you back this enhanced mojo, which underneath the hood, or rather not really underneath the hood, but when you deploy it to your production environment, assuming that you have a tool for visualization like Grafana, and you have some metric store. In this case, in this demo, I was using Prometheus. This enhanced mojo, when deployed, would communicate and send metrics at different parts of the pipeline to your metric store. And of course, you've got you can run queries either manually or through a data visualization tool like Grafana. This enhancement interface also generates dashboards for you with sensible defaults and like recommended ranges, if you will. So maybe it'll tell you, during training, there was this certain distribution of input data, and so we recommend that you monitor to see if there's any distribution, any shift in this distribution. And if there is shift in that distribution of your input data, then you might, then you might have data drift, or you may be able to catch emerging concepts, the emergence of concepts coming in.
So the Mojo had encapsulated that information about the distributions and all that.
Correct.
Oh, so that's how.
Correct. Yes. Yeah. Yes.
Can you do things as far as like adding data sources, or do you have to, so you have to rerun the feature extraction if you do something like that? You can't do that here, can you?
Sorry, can you repeat the question?
Can you do things like say there's a new relevant data source because of whatever drift has happened, or there's a new market that opened up that's important or something like that for financial folks?
Right.
Can you enact that here?
Can you
your
add?
model?
Can
Yeah.
you add a new column?
Yeah.
I-
A new data source, for example.
You would have to retrain your model.
Yeah.
Because your model encapsulates what the feature transformation, what the pipeline looks like, including what what inputs it expects. So if you're changing input, if you're adding or removing columns, then the model that you built wasn't trained to.
You got to go back up the pipeline.
Yeah, exactly, and retrain the model. This would have been nice too. Yes, please.
So how did the Prometheus server get added here? Somewhere you added a server, right, to provide data to Prometheus.
Yes. The interface that we were going to look at is makes a couple assumptions, and the assumption is that somewhere in your production environment you have a score. In our case, we're talking about Spark as our scoring environment, and it also assumes that you have some sort of metric store. Prometheus is really easy to set up, and so that through the interface would connect to your environment and recognize your metric store and also your data visualization tool. And so then this enhanced mojo, when it's generated, has that information encoded within it, so that once it starts to once things start to score, that mojo broadcasts the metrics to the appropriate place within your environment, the environment that you already have set up.
So Mojo is a server.
Please use mic.
Okay.
Okay, sorry, just understanding where is the server running, which Prometheus will poll from, right?
So no, the enhanced mojo wouldn't have any. There's no embedded server. So your environment, which is this bit in green here. So you may have a Spark cluster running, which does the scoring, and then somewhere in your environment, somewhere in your production environment, you may also have a Prometheus store or a metric store. So you set up a metric store somewhere, and then you also set up a data visualization tool, Grafana in this case, somewhere. So you set that up totally independent of the mojo and your model, completely independent. It's just through this process of enhancing the mojo that this enhancer, if you will, knows of the location of your Prometheus. And so the enhanced mojo really just carries information like, hey, when we're being scored, we should broadcast some information to the the Prometheus in the environment. Yeah, thanks for letting me clarify. Well, I wonder, so if there are any other questions, I'm going to actually get my hotspot set up in case we've got like We got maybe like 30 seconds. Let's see if we get any luck. Yeah, are there any questions regarding using Spark as for its ML pipeline, or using the H2O platform? Even if we have to go back, happy to clarify any of the concepts, or even before even talking like the early pipeline phases.
Another one. So these aspect Weaver UI demo you were giving, is there any dependency on H2O, or is it general pipeline able to add wrapper, or what do you call instrument any attributes in the pipeline?
Which phase specifically?
The aspect Weaver UI, which was adding that instrumentation for metrics, is that specific to H2O, or is it?
Oh, great question. Yes. Yeah, great question. And no, it is not specific to any specific type of mojo, as long as it's a mojo. But of course, in this case, you get a mojo from driverless AI, and so you have to have, or you can get one from H2O. But you do have to have a mojo, and so at the moment, the support only exists for mojo artifacts, which you do get through only H2O and driverless AI. I think I could be wrong about that, but yeah. My hotspot's not even up. That's weird. Oh. I don't know if they're going to kick me off, but if there are any other questions or...
No more questions?
Not recognized. All right. Well, yeah, I don't think we're getting any luck on the internet. But yeah.
Are you connected to the right network?
I was connected to the right network, but now I'm trying to connect to a local hotspot, which I'm not able to recognize at the moment. Yeah.
We can write the leftover information to that email.
Yeah, for sure. And I'll include some screenshots in the slides in case that helps. Yeah. Also, one last thing. Yeah, thank you very much. The takeaway should be that sparkling water lets you use the H2O platform, which a lot of folks want to use in the Spark environment, seamlessly. Also, we are hiring, and so there's some repos. But if you're interested, talk to any one of the H2O folks. We'd love to chat. Yeah, thank you very much.